Imagine this. Right beneath your feet, hidden deep inside the earth, lies a world no human has ever seen. The rocks down there are billions of years old. The temperature is so extreme that cooking oil would instantly vaporize into steam. The pressure is so intense it makes the crushing depths of the Mariana Trench feel gentle by comparison. And reaching that place is so difficult that no country in history has ever fully managed to do it. But China has made up its mind to make the impossible possible. Right now, as you read this, in the middle of the Taklamakan Desert in northwest China, a drilling rig as tall as a 24-story building is tearing through the earth meter by meter. Today, we are going to understand the full story of why China is drilling such a deep hole into the ground, who was ahead in this race before China, what dangers this work involves, and what the ultimate purpose of this entire mission really is. To understand why this matters, you first need to know how little we actually know about the inside of our own planet. And here comes a stunning revelation. We are the same civilization that sent robots to Mars, photographed the sun up close, and detected black holes millions of light years away. But when it comes to the ground beneath our feet, we are astonishingly ignorant. The distance from the surface of the Earth to its center is approximately 6,370 kilometers. The deepest hole humans have ever drilled is only 262 kilometers deep. That means we have reached barely 2% of the way to the Earth's center. If you imagine the Earth as an apple, we have not even fully pierced the skin. Almost everything we know about the deep interior of the Earth comes from studying seismic waves produced by earthquakes. When an earthquake strikes, its waves travel through the planet and change speed and direction as they pass through different materials. Scientists read these changes and build models of what lies below. It is like trying to understand what is inside a watermelon without cutting it open, just by tapping it and listening to the sound. The method works, but the picture it gives is blurry. Actually, pulling a piece of rock from 10 kilometers deep, placing it on a laboratory table, and studying it directly is an entirely different matter. That is exactly why the Soviet Union launched one of the most extraordinary scientific projects in history during the Cold War. The year was 1970. The Cold War was at its peak. America and the Soviet Union were locked in a race to conquer outer space. But at the same time, another race had quietly begun, not upward toward the stars, but downward into the depths of the Earth. The Soviet Union chose the Kola Peninsula in northwestern Russia to begin drilling what they hoped would become a monument to Soviet science. This location was not chosen for oil or for military reasons. It was chosen for pure science. The Kola Peninsula sits on the Baltic Shield, one of the oldest sections of the Earth's crust, where rocks as ancient as 3 billion years emerge at the surface. Scientists believed that if they could drill down 15 kilometers, they would reach the boundary between the Earth's crust and the layer beneath it called the mantle. Work began, and by 1979, the Kola Superdeep Borehole had already broken the record set by the American Bertha Rogers well in Oklahoma, which had reached 9,583 meters. By 1983, the depth reached 12 kilometers, and Soviet geologists were celebrating with great pride. But then disaster struck. In 1984, during drilling operations, a 5-kilometer-long section of drill pipe became stuck deep inside the borehole and snapped off, remaining underground forever. The team had to restart from a depth of 7 kilometers, drilling around the lost pipes. Finally, in 1990, the Kola Superdeep Borehole reached its maximum depth of 262 kilometers, a record that stands unbroken to this day. But what was found during that journey turned out to be far more astonishing than the record itself. Scientists had been absolutely certain that at around 7 kilometers depth, the granite layer would give way to basalt. This had been predicted by decades of seismic data and was considered established fact in geology textbooks around the world. But no basalt appeared. The granite continued all the way down, just hotter and more fractured. What had been interpreted as a basalt layer from seismic readings was actually granite that had been transformed by extreme heat and pressure. A geological model trusted for decades turned out to be wrong. The second surprise was temperature. Scientists had predicted that at 12 kilometers depth, the rock temperature would be around 100 degrees Celsius. The actual reading was 180 degrees Celsius. Heat was flowing out of the Earth's interior far more intensely than anyone had calculated. The third and most extraordinary discovery was water. At depths where rock should have been perfectly dry, compressed into a solid mass with no cracks or pores, water was found everywhere. Hot, mineral-rich water saturating the rock on all sides. This water could not have seeped down from the surface because the pressure at those depths would not allow it. This water had been trapped inside the rocks since they formed billions of years ago. This discovery completely overturned the scientific understanding of the Earth's crust, proving it was not a dry, solid mass, but something much more like a sponge saturated with ancient fluids. And alongside this water, microscopic plankton fossils were found at depths below 6 kilometers, fossils 2 billion years old. After the Soviet Union collapsed, funding dried up and drilling stopped permanently in 1995. Today, the site sits abandoned on the Kola Peninsula. The borehole is sealed with a metal cap bolted shut. The buildings have crumbled into ruin. But the data gathered there is still being studied and cited in scientific research all around the world. And now we come to China. On May 30th, 2023, in the Tarim Basin of Xinjiang province, China began drilling a new well called Shenditake 1. The Taklamakan Desert, where this is happening, is a world unto itself, with summer temperatures climbing above 50 degrees Celsius and winter temperatures plunging below minus 30. Nothing surrounds it for hundreds of kilometers in every direction except endless sand dunes and baking emptiness. And in the middle of all this stands a 72-meter-tall drilling rig capable of lifting 900 metric tons, the world's first fully automated ultra-deep drilling platform. On March 4th, 2024, a historic moment arrived when the drilling crossed the 10,000-meter mark, and China broadcast it live on state television. Then, on February 20th, 2025, drilling was completed at a final depth of 10,110 meters. This became the deepest vertical well ever drilled in Asia and the second deepest in the world, behind only Russia's Kola Superdeep Borehole. The operation required more than 1,130 drill pipes, with a combined weight of 350 metric tons, more than 20 different drill bits, and passage through 12 distinct continental rock layers. The final depth reached rocks from the Cretaceous period, between 66 and 145 million years old, the age of the dinosaurs. But the real question is why China did all of this. The first and most obvious reason is energy. The Tarim Basin holds the largest reserves of ultra-deep oil and gas in China. More than 83% of its oil and nearly 64% of its natural gas lie buried below 6,000 meters. China today is the world's second largest consumer of oil after the United States and the largest importer of oil on the planet. This dependence is China's greatest strategic vulnerability. Whenever tensions rise in the Middle East or with Russia, China's energy supply is at risk. Extracting oil and gas from beneath its own soil is the answer to that vulnerability. Shenditake 1 confirmed that oil and gas exist at depths greater than 10 kilometers. In the final stages of drilling, when the bit passed beyond 9,000 meters, clear signs of oil and gas were detected, strong enough that engineers chose to stop drilling carefully to ensure safety. The second major reason is geothermal energy. At 10 kilometers depth, rock temperature exceeds 200 degrees Celsius. This means beneath every square kilometer of ground, there's a colossal reservoir of heat waiting to be used. If that heat can be extracted efficiently by pumping cold water down and bringing superheated steam back up, it becomes an energy source that depends on nothing. Not sunlight, not wind, not another country's oil. Just the heat of the Earth itself, which will not run out for billions of years. According to estimates from the International Energy Agency, geothermal resources at depths between 5 and 10 kilometers contain energy equivalent to 50,000 times all the known oil and gas reserves in the world. The only problem is reaching them. That is precisely where ultra-deep drilling technology becomes the most critical piece of the puzzle. In November 2024, China also completed its deepest geothermal well on Hainan Island, reaching 5,200 meters through granite that formed 250 million years ago. The data from Shenditake 1 feeds directly into this geothermal program. The third reason is pure science, and it is no less important than the others. Every meter of core sample, the cylindrical column of rock pulled up from depth, is a page of geological history that cannot be read any other way. The minerals trapped in that rock, the ancient fluids sealed in microscopic pores for hundreds of millions of years, all of it tells the story of how the Earth evolved. Wang Chunsheng, the chief expert on the project, stated that below 9,000 meters, there was no technical reference to know what would come next. Every additional meter was a step into completely unknown territory. The fourth reason is earthquake monitoring, and this may be the most directly connected to saving human lives. China sits in one of the most seismically active regions on Earth. The 2008 Sichuan earthquake killed nearly 70,000 people. That earthquake originated about 19 kilometers below the surface in a zone about which geologists had very limited information. Having direct access to deep rock means sensors can be installed there to measure changes in stress and pressure inside the Earth's crust long before those changes reach the surface as an earthquake. Japan already operates such monitoring systems at shallower depths. China wants to push this capability to 10 kilometers and beyond. The fifth reason is national prestige. China has framed this project as part of its 4Deep program, which covers deep space through lunar and Mars missions, deep sea through advanced submersibles and ocean research, deep earth through ultra-deep drilling, and deep blue through naval and aviation expansion. Chinese scientists openly compare the significance of Shenditake 1 to landing a spacecraft on the moon or diving a bathyscaphe to the deepest ocean trench. And China is already planning the next phase, a well targeting 15 kilometers that would break the Kola Superdeep Borehole record. The engineering challenges involved in this work deserve their own story because they represent a genuine category of nightmares for any team of engineers. At 10 kilometers depth, the rock temperature exceeds 210 degrees Celsius. Standard steel drill pipes begin to soften. Electronic instruments fail. The drilling fluid used to cool the bit and carry rock fragments back to the surface starts to break down chemically. The downhole pressure reaches 145 megapascals, which is 1,450 atmospheres, more crushing than the deep ocean. The most terrifying risk is a blowout, when pressurized gas or fluid suddenly surges upward through the borehole with explosive force. This is exactly what destroyed the Deepwater Horizon platform in the Gulf of Mexico in 2010, killing 11 workers and causing the largest oil spill in American history. At the final depth of Shenditake 1, the borehole diameter had narrowed to just 20 to 22 centimeters, slightly wider than a dinner plate. Controlling a drill bit at the end of a pipe string thousands of meters long inside a tube barely wider than a plate is something one engineer described as driving a massive truck balanced on two thin steel wires stretched for 10 kilometers. The slightest deviation, the slightest vibration, and the pipe string can jam irreversibly, exactly as happened at Kola in 1984 when 5 kilometers of pipes were permanently lost underground. The final 9-10 meters of Shenditake 1 took 300 days to drill, roughly the same amount of time as the first 10,000 meters combined. China learned from Soviet mistakes and deployed technology that simply did not exist in 1970. Artificial intelligence systems monitor and correct the drill bit position with millimeter precision in real time. New pipe materials tolerate temperatures above 200 degrees. Operations are fully remote, with engineers sitting in the city of Korla controlling the drilling platform in the desert. And this project is not isolated. In July 2023, another ultra-deep well called Shenditake K1 began drilling in Sichuan province, targeting the same depth range, aiming for natural gas reserves estimated in the billions of cubic meters. Dozens of other ultra-deep wells are operating across the Tarim Basin. China is not just drilling one hole, it is building a network of deep Earth observatories. There is one more connection that few people discuss, but which makes this entire story even more layered. When the Kola Superdeep Borehole reached beyond 5 kilometers, scientists found rocks with extraordinarily high concentrations of gold, in some places reaching 50 grams per metric ton. Commercial gold mining considers 4 to 5 grams per metric ton economically viable. Mining at those depths remains impossible today, but it hints at what may be waiting deeper in the Earth, resources we have not even begun to imagine. We live on a planet whose surface we know better from orbit than we know its interior from the ground. We have detailed maps of Mars, with resolution down to a few meters, produced by NASA orbital cameras. But a map of Earth's interior at 10 kilometers depth is still a collection of blurry estimates. Every ultra-deep borehole opens a tiny window into that unknown world, and what it reveals is almost always different from what scientists predicted before they drilled. The Kola Superdeep Borehole found granite instead of basalt. It found ancient water where no water should exist. Shenditake 1 found rock structures that did not match the geological models built from surface data. And near its final depth, it found active signs of oil and gas that made engineers proceed with extra caution. So when we return to the question of why China is drilling the deepest hole in the Earth, the honest answer is all of the above simultaneously. Oil and gas to reduce dependence on imports. Geothermal energy to power the economy without carbon emissions. Scientific data to understand the planet we live on. Seismic monitoring to predict earthquakes and save lives. And national prestige to demonstrate that China can do what only Cold War superpowers once dared to attempt. But perhaps the biggest reason of all is this. Whoever controls access to the deep Earth controls what comes next. Oil, gas, geothermal energy, rare earth metals, ancient water, all of it is down there. Ultra-deep drilling may become in the 21st century what space exploration was in the 20th, the next great race that reshapes the balance of power on Earth. The Kola Superdeep Borehole sits sealed and forgotten on a windswept peninsula in Russia, its buildings in ruins, its record still unbroken after more than 3 decades. But the data it produced and the lessons it taught are very much alive. China has absorbed those lessons and is pushing further. We live on a planet whose interior we have barely touched, and yet the effort to understand it continues, 1 meter at a time. The next time you stand on solid ground, remember that beneath your feet lies a world still waiting to be discovered. And right now, somewhere in the heart of a vast desert, a machine the size of a skyscraper is drilling toward it.